Welcome to this talk on TestBalloon. So thank you for choosing TestBalloon today. I'm Oliver, and let's dive right in. I have a lot to talk about. So why are we here? We love to create working systems, right? We love to ship something that's actually useful and working correctly. But sometimes our systems look like this. So it may not be clear at first sight, but it's clearly broken. And fortunately, we have tools to move from here to there, which is our testing toolkit, which contains of test frameworks and their add-ons. This is what this talk will be focusing on. And also assertion libraries and specialized tooling like for mocking, flow testing, screenshot capturing, you name it. So the most decisive factor deciding what you can and cannot do easily in testing is the test framework. So let's give a job description. First thing a test framework needs to do is it needs to find your test, because we have no main function in tests, right? And even if you had a main function, you wouldn't want to wire hundreds of tests into that single main function. So the test framework needs to do that for you. Second is it needs to provide a structure for tests. If you're familiar with JUnit, which I guess most of you are, we have this class method structure. But there's also frameworks providing multi-level hierarchy, and TestBalloon is one of them. Obviously, it needs to run tests, and with test frameworks, it doesn't need to run all the tests all the time. Sometimes in development, you just want to run a single test. So fourth, we need to provide some test state management. We have test fixtures, which provide state for our tests, and we should have a freshly initialized fixture per test. This is what we expect a test framework to do. And finally, of course, we wanted to report the results back to the IDE, or with CI to HTML files or whatever. So there's also these assertion libraries, which are frequently shipped with test frameworks, but they don't have to. We can typically use them independently. So if we look at the Kotlin test framework today, at the landscape today, this is what it usually looks. We have Kotlin test, a very basic test framework, providing the most basic capabilities of the JUnit frameworks that we know from the JVM. Then there's JUnit 4. The Android developers are still mostly on JUnit 4. And there's JUnit 5 and 6. Both are JVM-only frameworks. And all of the first three frameworks don't have a DSL, so they're not really Kotlin first, right? They feel a bit alien. They come from the Java world. And the fourth framework that's frequently used is Kotest. And this is the only DSL-based framework that's in common use. It's multi-platform. It has a DSL, at least partially because on a top level, it is still using classes. And the interesting thing about all of these frameworks is they were created about a decade ago or even earlier. So what did the Kotlin landscape look at that time? The Kotlin multi-platform story wasn't there yet. Kotlin on Android came in 2017. And there were no coroutines with structured concurrency. So a lot happened in 10 years. And what's probably most important, we've had a decade to learn how to use Kotlin best. And we've learned to design APIs that were easier to use than what we did 10 years ago. So anyway, but why not continue to use these traditional tools? What could possibly go wrong? And it turns out writing, reviewing tests with these old tools is not always quick, because sometimes capabilities are just missing that we might expect in test framework. We'll get to this a bit later. And there's also a lot of copy-paste with test frameworks, especially with Kotlin test, where we have no method of parameterizing anything. And there's lots of boilerplate. These old test frameworks are quite verbose, way more verbose than what we used to when we use Kotlin DSLs. And it can also be outright difficult. Kotlin test frameworks have complex APIs. So the more capable stuff you want to use of JUnit 5, for example, the more complex its API becomes. We're also seeing integration gaps. Some tests may only work on the JVM, not on the other platforms, because the functions the test frameworks provide are not the same everywhere. And again, we need to deal with bloat, because these frameworks are verbose, and that means for us more code to review, more code to write if we still write it. But if agents write it, then we need to review it anyway. And then if these things happen, pushbacks creep in, so tests don't get written, or they don't get reviewed properly. When we have repetitive code or complex setup, these become refactoring liabilities over time, right? Whenever we want to change our system, we need to review our test setup, whether it still matches what we changed. And finally, with Gen AI, bloat increases token costs and may blow our context windows, so the quality of content these AI tools produce goes down. And in the end, that's not fun. We may feel that we are losing more control than we should. And then we lose confidence in our releases, and that's not fun. So what could be done about it? Think about what would we do if we were designing a test framework for today's ecosystem. We certainly have coroutines first there because they're now everywhere in Kotlin. We'd also have a framework that's multi-platform first, not as an add-on. But what's maybe the most important, we could build on a decade of API design evolution. So now we know how to use Kotlin in the right way. That means we would expect extensible DSLs from a test framework and not these class, method, structure, things that are hard to extend or not at all. And we would expect scope friendliness. These before-after methods don't match well what we do in Kotlin. Simple thing we can't just do with these before-after, insert a coroutine context element in that because we have no scope. And again, most important, we could build on the experience gained from the predecessors. I have been helping to maintain Kotest for 3 years, and the complexity of maintaining this was one of the factors motivating me to start TestBalloon. So in this case, how could you benefit if there was such a new test framework? You could write your tests easier and faster. You could focus more on domain logic, and this is in the end what matters. And what may be even more important, especially in the age of AI, you could level up comprehensibility because there's less bloat, which means the time to correct understanding would be way lower. So, and as you guessed it, this test framework exists. It's called TestBalloon. And let's dive right in, compare with JUnit 5. So not the basic Kotlin test, at least use JUnit 5 comparisons. So the basic test in JUnit 5 looks like this. We have that class, we have these test annotated methods. We can use expressive names to a certain extent, unless you put in a dot or a slash somewhere, you're fine. And we can even have nested classes. In TestBalloon, the same thing looks like this. We just have 2 functions, test suite, which group things, and the tests. And the rest is plain Kotlin. At the top level, we have a property, because we need to start somewhere, right? The language needs an anchor point. With these tests, what do we gain? Although it's very simple, in code size, we already achieve 5% savings. Same test. May not seem much. With a German work schedule, 5% is about 11 work days a year. So, but that's too easy, right? So let's go on with the usual tests, like where we use fixtures. Fixture, I'm using the term in JUnit terminology, which means a state holder, where we could put in state, which we could then reuse in several tests, and we expect that state to be fresh for every test. In JUnit, a fixture test would look like this. As you can see, we have a weather service. This weather service is modern Kotlin, coroutines based, and we use API calls on that service to find out temperatures and then compare them with expectations. As we use coroutines, we need to use late init for the property we use for the fixture because we can't run coroutines there. We also need to use run test everywhere to have coroutines inside our tests. Same thing in TestBalloon, looks like this. We have a test fixture function where we just put in our fixture object, and that's it. And then we say, okay, provide this as a context for each test, which means we now have it as a this pointer in each test and can invoke the methods directly. coroutines are everywhere. We don't need to configure anything or don't need to do anything special to have coroutines available where we need them. So this is what it looks like. Again, let's compare sizes. Right now, it turns out we're already saving 28%. Right? Let's go to write, let's go to review. So let's go one step further and handle variance and edge cases with parameterize tests. So we write a common test once, and then we want to test its variance and edge case by just giving parameters to this common test case instead of copy-pasting this 10 times or so. An example from a TestBalloon user, actually, they have a UI performing a login journey, and they want to make sure that this works on various screen sizes, on mobile, on desktop, on tablets, and in the browser. And they just use screen size parameters, and then run the same test for each screen size, and can be confident that their application actually works on all the screens they want to support. So this is what you would do this, what you would do it in JUnit. You would use annotations like parameterize class, and then a method source, where we provide a method which is stringly typed connected to that class. We'd also lose type safety. So if we make a mistake at these points, we get runtime errors instead of compile time errors. And also data flows all over the place. We have our parameter providing function, and then it flows through the constructor of our test fixture and then down to the test methods. This is not really easy to review. In TestBalloon, nothing has really changed. We invoke that test function at some point, and the rest is just plain Kotlin, right? The rest we've seen before. We have the test fixture, we have as context for each, and if we put these tests in a loop, nothing really changes. What do we gain in terms of code size? We're now at 45% less than what we need with JUnit, and we don't have this crazy data flow. So now you can say, wait, there's an alternative. Why not just put that loop inside our test? Yeah, this is what we could do with JUnit, just put the loop inside the test. But then what happens is we lose visibility. If we run that test, we never know whether we have checked one test case or 3 or maybe none. We don't know. It's just green. We don't know what is green. So we don't know what was actually tested. And if some test fails, we wouldn't immediately see which one. Yeah, so distinct tests provide us visibility. So it's very important to be able to just put tests in a loop when you parameterize them. One step further, we can test across multiple dimensions. Until now, we used our weather service, and we're just testing temperatures at 3 locations. But we want to make sure that this works across all 4 seasons. So we have 2 dimensions of testing. And again, with JUnit, you can actually do something like this, but then you end in dynamic tests. And while this is possible, with dynamic tests, you lose all the usual fixture support, because now you no longer have the fixture set up per test, but you have it per test factory. And then now all tests share one fixture. Yeah, so it changes the execution model just because we want to parameterize. And in this example I've just chosen a single dimension to parameterize because the code gets so bloated that the screen size would be not proper for an audience of this size. Okay, so with these things, we can easily get foot-gunned. In TestBalloon, nothing really changes. Yeah, we use 2 dimensions. We use our test suite and test invocations. The rest is plain Kotlin. There's no annotation, API systems to learn. Just invoke the familiar functions inside a loop. Next case, we could do stepwise testing. Our servers needs us to connect to it. And now we could do it. Let's connect to it in the first test. and then test 3 temperatures, relying on that the service is connected. And then we can even simulate, for example, an event that changes the test data. In this case, it's a thunderstorm, where we would expect the temperature to drop to some level and then remain at that level. All right? Suppose we wanted to do this. In TestBalloon, we would change a single thing, but let's first look how we would do it in JUnit 5.6. And the answer is, as always, like in Jurassic Park, right? Nature will find a way. So it's possible, but it's enormously difficult. So we're again in this state, which is not fun. In TestBalloon, it's just like this. We change a single thing. We change as context for each into as context for all. And now we have shared state for all the tests that are in the scope of that. So that's way easier. It doesn't end there. TestBalloon supports customizability. And we need to stop comparing with JUnit because it would become so complicated to rebuild each case in JUnit. Let's suppose we want to run a test repeatedly because in this case, we want to make sure that the oxygen level is at the right scale. And we're only confident if we run this for a number of successions. So we might want to write a test function that does it for you, just provide a number of iterations, and then run our tests inside that. And it turns out, even if that function may not be there out of the box, we can easily provide one. And this is how we would do it. Like with any other DSL in Kotlin, we would look at what does the standard test function look like. And a simplified version is this one. So this is the signature of TestBalloon's standard test function. And if we would now want to expand on it, we just copy it and adapt it as needed. In this case, we put in the iterations, we put in the loop, we call the original function, that's it. It's plain Kotlin. It's what we would do with any other DSL. So, and it turns out that this customizability of the DSL actually goes really far. What you're seeing here is a test how the folks in BDD-style Cucumber would write it. It looks totally different from anything we've seen until now, but it's still just built on the public API of TestBalloon, a custom DSL, nothing else. And we even get IDE run gutters for that. So this is not the only way to customize tests. Adapting the DSL is one, but there's another one. Sometimes we want to configure behavior in a cross-cutting way. So maybe we want to disable tests or part of them conditionally. We might want to use a specific coroutine dispatcher for a set of tests or create a timing report for a set of tests. So we wouldn't want to write a DSL function for each of these cases, which then would be difficult to mix. We need cross-cutting behavior. And the final one is we might want to handle flaky tests. For example, on Android, you never know that in the emulator something might pop up or on the real device. So you repeat tests for a certain number of times. And if they succeed at any point, then it's OK. And TestBalloon provides a configuration mechanism for all of these. Every element has a test config parameter. In this case, it's test, where we say, OK, let's insert that coroutine context element into that test. And there we have it. We could do the same with a test suite, same test config parameter. Let's say, OK, we want to invoke our test not sequentially, which would be the default, but run them all concurrently so that it's faster. And for those that are familiar with the composed modifier system, this is exactly the same thing. It's a decorated chain. We start with a neutral test config object and then call functions on that object to enrich the configuration. And this is actually very flexible. And we can also extend it. We can write our own custom functions extending that test config class, like this one. When we want to run stuff only on CI, we need to determine, OK, are we on CI? Then nothing changes. If we're not on CI, we disable the test. And then we can invoke it like shown below. If you try the same with JUnit, you would have to use annotations again and lose type safety. Nothing like this in TestBalloon, because it's Kotlin first. So Last thing, custom wrapper. We could just wrap whatever we want around a test. This is what I call scope-friendly. So we have that test config function around each test, which is part of TestBalloon. And this gives us an action parameter, which is the actual inside test to call. And we can put this call wherever we want and put around it whatever we want. In this case, it's try-catch. It's also a repeat loop, so that we can say, OK, let's repeat this test for a certain number of times. If it succeeds once, it's OK. Only if it fails for that number of times, then we really fail. And this is the way to handle flaky tests. And what makes it easy is that this configuration is available across the entire tree of test elements. We have already seen test suits and tests shown below. And on the top of all of them, the parent of everything in one module is the test session. So if we want to configure a certain thing for a test, we just put that test config parameter there. If we want to configure it for a test suite, put it there. If we want to configure it for the entire module, just put it in the test session. As easy as that. One single mechanism to configure anything everywhere. Test compartments are special. We can ignore them for now. So let's recap the API. It's just 3 functions. It's test suite, test fixture. And then it's our test config thing for configuring things. And this is the entire API. The rest is plain Kotlin. So now navigating the Kotlin test framework landscape would be incomplete without looking at Kotest. So let's compare with that. TestBalloon and Kotest are both DSL-based frameworks. They both support multi-level nesting, parameterization, and they're both multi-platform. The differences are mainly in API designs. So TestBalloon has these test fixtures at any level, as you have seen. In Kotest, they're really there at the top level. Only Kotest has had them on the low levels. But this has shown to be not working correctly under our circumstances, so these are now deprecated. With configuration, TestBalloon has the single configuration mechanism that works at any level, and it works with one class, the test config class. With Kotest, we have 4 levels of parameters with separate parameters set for each level, and 44 classes. This is not a typo, 44 classes to configure the rest. Also, the custom DSL in TestBalloon is easier to use because it's one DSL for everything, while in Kotest, we always have to discern what's going on the class level and what's going on the levels below. So it's an easier design on that level. And to show an example where these differences matter, let's look at this familiar test set and then change it. So here we have fresh state for each test because we've invoked as context for each, right? Now, if we want to put the first 2 tests in another suite, we would just write it like this. And nothing would change. We still have the same fresh state per test. If we would do the same with Kotest, it would look like this. We would start with a class, because at the top level, Kotest uses classes. Then we would have to say, OK, for fresh state, we would have to set an isolation mode. Isolation mode is instance per root, then we get fresh state at each test. So it's a bit more verbose, but otherwise looks pretty much the same. But now, if we want to insert another suite, where we could use the context function in Kotest, then everything changes. Because now, we would get fresh state per element that's below the class level, and not per test. And this is almost never what we want. And also one major difference is, and what motivated me to try something else, is size. Kotest has about 65K lines of code for the framework. Just for the framework, no extensions, nothing else. And no assertions. And TestBalloon is at 10K lines of code, and both do the same thing. So it's an 84% reduction in size. Now imagine what's easier to maintain. Where both meet is, I appreciate Kotest assertions framework very much, and this works beautifully and TestBalloon. And now in that context, over to Bernd, who did some really serious stuff with TestBalloon.
Can you hear me? Yeah, perfect. So I'm Bernd. I work for ASIC Plus, and we have been doing Kotlin multi-platform in production for 5 years now, which means that, thanks, we have experience and we have opinions. And today I will be talking about Signum. This is our Kotlin multi-platform first cryptography library. It has some downstream integrators with large usage numbers. And this is not about bragging, but this will become important for context later on. And yeah, it ships with a 100% pure Kotlin ASN1 codec. It gives you all the data classes you would expect for cryptography, like certificates, JSON web tokens, and so forth. It interoperates with the JCA on the JVM. It supports hardware-backed cryptography on Android and iOS, and it has first-class hardware attestation support. So we support all the KMP targets for our core, and we obviously support the targets where we need interoperability with for the delegation of cryptographic operations. So what do we need to cover? Well, we have to cover the ASN1 core and encoding rules. We have to cover the X509 profile and the PKCSN profile. We have to cover COSE, HOSE, JCA interop, Android and iOS interop, attestation, and so forth. So we have more than 600 pages of specification we need to more or less cover. And for context, Mikhail Bulgakov's Master and Margarita tops out at just shy of 450 pages. That is including a foreword for the 50th anniversary edition. One side of this is very enjoyable. The other is cursed knowledge that will make your life worse because you cannot rid yourself of it once you know it. So how do we test all of this? Well, we throw everything at the wall and see what sticks. That means millions of tests, literally, not figuratively. So, of course, you don't write those tests, but you use the nice generators that Kotest gives you to do that. But we still keep those manually written ones for the happy path and for some edge cases and so forth. And when in doubt, we just throw more test data at it. Always a good idea, if you ask me. So, I've been telling you we've been doing multi-platform in production, so what are multi-platform first best practices when it comes to testing? Well, you test on all targets, obviously. You test against outside known good implementations where you have them, and this means that often this is only one target, but you can extrapolate the results to other targets if you know what you're doing. And you want to execute your tests concurrently to catch hidden global mutable state because, surprise, surprise, this differs from target to target. And you most definitely want to target the JVM and Android separately because Android is not a JVM and the JVM is not Android. So as soon as you get close to the hardware, things get different. And as soon as you get close to the operating system, things start to differ as well. And this is true for production code and for test code, which means that if you target Android, don't ship a JVM artifact, but use the Android SDK, the Kotlin Android plugin, and ship a dedicated Android target. But this also means you have to use the emulator and real devices for testing. And by extension, this means that roboelectric and host-based unit tests are no good at some point. So Signum is a bit older than TestBalloon, so how did we achieve those goals for Signum? We were using Kotest for the lack of alternatives, and to be honest, it used to work great, really. So before Kotlin 2.0, everything was pretty much awesome. Until it wasn't, and it still has no proper Android support, and the feature creep Oliver mentioned also is an issue if you want to maintain large test suites and configure lots of knobs. On JavaScript targets, it's not as you would like it to be, so yeah, all in all, not so great for complex multi-platform projects. And it even blocked us from trying out early access previews of Kotlin, which means that when the releases were ready, Kotest caught up, errors showed up in our code, errors which we could not report to JetBrains before the final releases of Kotlin were prepared. So we migrated from Kotest to TestBalloon. We wanted to keep our syntax, so we did not want to change the source of our test suites, at least not by much. So the property testing, the data-driven testing, the test size, all that is really awesome, and we still want to benefit from that. So we need to bridge the Kotest libraries to the TestBalloon framework. We thought, well, let's try AI and have it do that. Didn't work out, and then you go overboard and you end up with writing your own collection of add-ons for TestBalloon because it has such great DSL capabilities so that you can all the things from Kotest and then some. So for Signum, or in general, what means that? If you are familiar with Kotest's data-driven testing, you can do something like this. You have a test suite, and then you have a nested suite, which generates 4 test suites that pass a number downstream, and then you generate 5 tests that generate a nullable string and pass it down. And of course, this line will fail here in 4 out of 5 cases, and the report will look like Oliver showed you. And you have your 16 failing tests and 5 passing, and you can click on the stack trace and get back to where it failed. So this is nice for a small example, but if those numbers grow larger and nesting grows deeper, this will not work anymore. Your test reports will become too complex. So we introduced ways to make those compact. This degrades the overview, I will give you that, and because it will only show 4 tests, but if you look below, you can see you have a summary of 1 test for one of these nested runs that is okay, 4 that are failed, and you can still click the stack trace and get taken back to where the actual failure occurred. So you don't lose any insights, but your test reports become tiny. What does this look like for complex projects with complex test suites? So I will show you one example that is part of our test suite that is testing the script function. And the code itself is not that important, but you have 1, 2, 3, 4, 5, 6 level of nesting with a single assertion at the very bottom. And if you bloat that up and keep generating all those nodes for tests, this will just explode. Your report will become too large. Your CI will fail for resource exhaustion and so forth. So the full run of the whole Signum test suite tops out at just 42,000 tests for the JVM and only about 14,500 for JVM and Android each, and some thousands for the other targets. When in reality, we're talking millions and millions of data points being tested. So the migration, by the way, from Kotest to TestBalloon, once we had our add-ons package ready with the custom DSL, took like 1 afternoon, and it was just running. So what did we gain from this, and what did we learn from this? Well, we can now really parallelize the hell out of everything and catch hidden global mutable state for free. Trust me, it's there. You will catch brittle initialization orders. You will catch Heisenbugs because you can just run your tests over and over again, and we can test on real hardware, so those 5 million users downstream don't get surprised in practice. Over the course of 3 months, we caught like 6 issues for the whole user base that we didn't test. The I/O simulator is cursed. Ask me later if you must. So the migration was worthwhile. It surfaced hidden bugs. I'll hand back to Oliver now. Thank you very much.
So as you can imagine, you don't have a migration like this each day, right? So I was a bit curious what to make of it and thought, what about velocity? This would be the only time to have a real-world test set, and a giant one, to compare the speed of Kotest with that of TestBalloon. So I tried. I was using a part of Signum, the AS1 suite, and due to the different compacting levels Bernd mentioned, I had the option of separating those into 33K tests or another number. So starting with 33K tests, it looked like this. Sequentially, both test frameworks are about the same speed, right? Nothing much changes. But when parallelizing tests, there was almost no difference with Kotest and half the time with TestBalloon. So one step further, try the same thing with 1.7 million tests. It's the same amount of data points tested, just another distribution, another granularity of the tests being produced. So here again, with Kotest, parallelization gained 11%, and with TestBalloon, it gained 74%. So I thought, why? And it turns out that the difference is deep versus shallow parallelism. TestBalloon, when you select concurrent execution, parallelizes across the entire test tree, right? From the top down to the very bottom, regardless of the number of levels. So your tests could be 11 levels deep, everything will be parallelized. In Kotest, it's actually the way only the top 2 layers can be parallelized, and everything below them runs sequentially. So if we have a situation like this where we have 2 top-level suits and then 4 below them, and then all the tests down there, which is a very simple test tree, so real-world ones get way deeper, then it would look like this. Given enough cores, TestBalloon would run all the tests in parallel, and Kotest would just parallelize the top 4 suits, the top 2 levels, and the 4 suits that are then coming out of this, and then execute everything within these suits sequentially. So this explains the time differences. Of course, like this, it always depends on the distribution of your tests, the distribution of long-running versus short-running tests. And this is also why I didn't want to create an artificial benchmark, which in the end could show anything but use a real-world test set. So where to use TestBalloon? It actually supports all Kotlin platforms. So wherever Kotlin runs, TestBalloon runs, and it does so in first-party quality. This was a very important goal in TestBalloon, not to be worse than any of the more native frameworks. And actually, fun fact, for the Android folks, we have roboelectric integration. And it turns out that the roboelectric, which normally needs a JUnit forerunner, they have started to provide an integration into JUnit 5 to level it up a bit. And this integration was vibe-coded in December 2025. And now you can expect what happened is sitting in a review queue until today. For TestBalloon, I just took some of the APIs that were created for JUnit 5, extracted them, and TestBalloon supports roboelectric integration since February 2026. Build tools, build systems and test infrastructure. You can run all the familiar Gradle test tasks. You can even use Gradle test selection, which is not supported on JUnit, for example, for these test hierarchies. Yeah? If you go beyond class method selection, no other test framework supports this via Gradle filtering. You can have the normal Gradle test reports. And what's even supported here, it's still called Amper. Now it's the Kotlin toolchain. Even TestBalloon even runs with that. And on JUnit 5 and 6, also on JUnit 4, TestBalloon can coexist with other JUnit frameworks in the same module. So if you migrate, you can do so at your own pace. In IntelliJ, you have run gutters, hierarchical test tools, test results window, what you would expect. So takeaways. If we have a 2026 style Kotlin test framework, we have a concise API which lets you start easily and move quickly because it just doesn't take time to learn stuff, right? You have a very short learning curve. The DSL and its flexibility supports you as your projects grow and as you scale up or scale out across target. Yeah, TestBalloon will always be there. As Bernd has shown, TestBalloon is pretty robust. And the deep parallelization offered by TestBalloon cuts your cycle time so you get results faster. And finally, the integration is at a level that just works for you on all platforms. And I find this is very important. You don't want to fight your test framework. So Stable 1.0 was released last week, so it's ready for you to use right now. And thank you. And this was after 50 public pre-releases, and Bernd's been using it for more than half a year.
Yeah, like that.
Something like that. Okay, so our hope is that instead of being cumbersome, writing or reviewing tests becomes easy and fun. And so create great tests, release with confidence every time, even on Fridays. Yeah, with that, thank you. Don't forget to vote.